Hello class, welcome to Algebra Lesson 4.2, which is all about solving systems of equations by substitution. By the end of this lesson, you should be able to solve a system of equations using the substitution method. So in the last video, we talked about solving systems of equations. So when you have more than one line that intersects, solving them using the graphing method. So that way you could actually see where those lines intersected. Or maybe they didn't intersect and that's how you got a no solution. Or maybe they ended up being the same line, so it was infinitely many solutions. Today, we're going to try to do that same idea but without actually graphing it, because I know usually people aren't all that excited to graph, and also like the last example we did with lesson 4.1, it didn't work out to nice numbers. It was like 8.1 something and 169.6. That's not really feasible to graph. So we're going to learn a more precise method, and that's called substitution. And so substitution is a method you're going to use when you have a variable that has a 1 with it, or meaning it doesn't have a number in front of it. So a prime example is if we look at this first equation here, it's just y equals, right? It's not 5y equals, it's just y. So the first key to knowing when you're going to use substitution is when you have a variable all by itself like that. So now let's figure out, how do we solve without actually graphing this? So if I were to tell you that y equaled 5, and I said I want you to plug that into this equation, you'd probably say, okay, 3x minus 8 times 5 is 40 equals 4, and then you would say 3x equals 44, and then x equals, that would be 14 and 1/3, okay? So you would probably do something like that. You'd plug it in, and then you'd solve for x. We're going to do that same idea, except we don't have just a nice y equals 5. Instead, we know that y equals this entire thing. So I'm going to take this entire thing and plug it into my other equation where the y exists. So I'm going to say 3x minus 8. And then instead of y, I'm going to use some parentheses. I'm going to say 6x plus 7. One common mistake that people make is they either forget to do the parentheses, or maybe they just multiply this first one and then you carry down a 7. Make sure you put everything from the y into parentheses and make sure you distribute everything. Another not as common error is people will forget to bring like this first part down for whatever reason. So anyways, 3x, just be careful. Negative 8 times 6x is minus 48x. Then negative 8 times 7 is minus 56 equals 4. I'm going to combine my like terms, so I have 3x minus 48x. It's a negative 45x minus 56 equals 4. And then I'm going to solve it just like I've practiced solving equations all year. I'm going to get x all by itself, so I'm going to do order of operations backwards. That means I'm going to add 56 first, so I have negative 45. X equals 60, and then I'm going to divide both sides by negative 45, divide both sides by negative 45, and I get x equals 60 divided by negative 45 is negative 1 1/3, so negative 1 1/3. Okay, so now remember, we're always trying to solve for an xy coordinate. So we just figured out negative 1 1/3. We figured out our x. Now we need our y value. So once you have that x value, you're going to plug it into the equation you haven't plugged anything into yet. So I'm going to go back to that first one. I'm going to plug it in there. So I'm going to say, I'm just going to change colors to maybe make it a little easier. Y equals 6, and then instead of x, I'm going to say negative 1 1/3 plus 7. So if I do negative 1 1/3 times 6, that's negative 8 plus 7. That is, so negative 8 plus 7, that's a negative 1. I have y equals negative 1. So now I know what my x equals, I know what my y equals. So my solution is negative 1 1/3, comma, negative 1. Okay, so that is my solution for this problem. I'm just going to quickly recap because I know this can sometimes take a little bit to get used to. We started with these two equations. I had a y equals 6x plus 7. So since I already know what y equals, I took that 6x plus 7. I plugged it in for my y in my other equation. That's how I ended up over here. So I had 3x minus 8 times the quantity of 6x plus 7 equals 4. I distributed. I combined my like terms. I did order of operations backwards, started with addition. Then I divided by negative 45 to get negative 1 1/3 as my x value. So I wrote that as part of my solution. Then I took that x value and I plugged it back into an original equation I had, y equals 6 times x plus 7, to get y equals negative 1. You might be asking me, Ms. Johnson, does it matter what equation I plug that x value into? And the answer is no. If you had wanted to plug that into this second equation, you would end up with the same answer. I just like to, since I wanted to know what y equaled, I figured I would pick the equation that has a y equals. Like I said, you can take that x value, plug it into either of the equations. All right, now it is your turn to try. You have y equals 2x minus 1, and then 2x plus 3y equals negative 7. Good luck. All right, for this first question, hopefully you took that y equals 2x minus 1, you substituted it in to that y in the second equation, and then when you solved for x, you got x equals negative 1/2. Then you took that negative 1/2 and you plugged it into your other equation, and you should have gotten y equals negative 2. Once you had that number, you now had your x and your y values, which means you have your ordered pair. So my solution as an ordered pair is negative 1/2, comma, negative 2. That means that those two lines, if you were to graph them, would intersect at negative 1/2, negative 2. Okay? Now, example 2. Just like in the graphing video, we talked about how to tell if there are infinitely many solutions or no solutions. So let's take a look at that. Here we have y equals 3x plus 1, and then 6x minus 2y equals negative 2. So since I know what y equals, and honestly, if this was an x and this was a y, you could do the same thing. You would just plug it in for x instead. So then the first thing you would solve would be for y. So just kind of flip the order of everything that you did, but it'd be the same process. So I just want to point that out because I know that happens on the homework a few times. All right, so anyways, back to the start here. Y equals 3x plus 1. I'm going to plug that in for y. So I have 6x minus 2. And then instead of y, I'm going to do parentheses 3x plus 1, parentheses, equals negative 2. I'm going to distribute negative 6x minus 2 equals negative 2. 6x minus 6x, those cancel. So I have negative 2 equals a negative 2. Okay, so once your variable disappears, if you end up with a true statement like this, that negative 2 equals negative 2, that is a special case, and that special case tells you that you have infinitely many solutions. That means that those two lines, those two equations, are the same line. Okay? So we have the same line or infinitely many solutions. All right, let's look at this next one. This time I have 5x minus y equals negative 4, and then I have y equals 5x minus 4. So I'm going to say 5x, and I'm going to take that y equals, and I'm going to plug it in like that. So I have minus, and then parentheses, 5x minus 4, parentheses, equals negative 4. So 5x, and then a lot of people struggle with this. When there's a negative here, and then there's no number, there's no visible number that you see, remember there's always a 1 there. So some people will just forego, they will skip writing those parentheses because they think they don't matter. That's false. So you're going to take that negative 1, you're going to multiply it by 5x. So I'm going to say negative 5x. And then negative 1 times the negative 4 becomes plus 4 equals negative 4. So then I have 5x minus 5x, that cancels. Then I have a positive 4 equals a negative 4. So whenever they equal different numbers, that is no longer an infinitely many solutions. That is now called a no solution answer. Okay, so that means those two lines are never ever going to touch. Okay, so that is a no solution. Now I want you to look at these two equations and figure out, is it infinitely many solutions or no solution? Good luck. All right, for this problem, hopefully you ended up with a 5 equals a negative 4, which means no solution. All right, let's jump into our last example, and this is word problems. So something you're going to discover with systems of equations is they have a lot of useful real-world kind of uses. And so there's going to be quite a few word problems. So if you struggle with converting word problems into equations, be sure you ask for help because this is not going away this chapter. Okay, this is here to stay. You want to make sure you understand this. So Nate starts a lawn mowing business. In his business, he has expenses and revenue. Nate's expenses are the cost of the lawnmower and gas, and his revenue is $25 per lawn. At what point will Nate's revenue exceed his expenses? Okay, so since we're talking about systems of equations, we know that we need not one equation, we need two. And they kind of listed two for us, right? They talked about the expenses, which actually, I'm going to be smart. I'm going to say expenses. I'm going to write that with kind of that red color. So expenses. All right, expenses is how much he has to pay, right? And we don't know how much the lawnmower and the gas are. We need to use the information from the picture that I realized I forgot to put on this slide. So I'm going to tell you the lawnmower is $200. And the gas is $2 per lawn. Okay, so the gas is $2 per lawn. So his expenses is 200 y equals, because we don't know what his total expenses are. No matter what, he has to pay $200 to get that lawnmower, plus, and then $2 for every lawn he mows. We don't know how many lawns he mows, so I'm going to use X. Then, for revenue, so the money he makes rather than spends, revenue is that fancy word. So revenue is, he gets $25 every lawn. So the amount of money equals $25 times every lawn. Okay, so those are my two equations. Now, if you look at this, I have a y equals and a y equals. This is a little different than what we've been doing so far. Everything I've had is like y equals something, and then I had another equation where it was x and y on the same side. So the cool thing, but if we have a y equals and a y equals, if I were to say y equals y, so I'm just kind of going off on a little tangent here, okay? So we're going to ignore expenses and revenue for now. If I were to say y equals y, would you agree with me? Would you say that that is a true statement? Hopefully you said yes. If you didn't, let's think about it a different way. If I said 3 equals 3, would you agree with that? Again, hopefully you said yes. If I said 1 million equals 1 million, would you agree? Hopefully your answers to this are yes. This is just a little more abstract. We just know y equals y. Anything equals itself. That's always going to be true. So, instead of just writing y equals y, that first y I'm going to replace with my expenses. Because I want to know, my expenses. So 200 plus 2x. Because I want to know, when will my expenses equal my revenue? So then for the second y, I'm going to replace it with my revenue. So 25x. So whenever you have a y equals and a y equals, all you have to do is set those two equations equal to each other, and then you solve from there. So I'm going to go back to a new color. All right, so now I see 200 plus 2x equals 25x. So I'm going to combine my like terms. I'm going to say 200 equals 22x, and then I just need to divide both sides by 22. So I get divide by 22, divide by 22, and I am left with 9.1 equals x. So I know that they will be equal at about just over 9 lawns. So I just realized I have a calculation error. I'm going to back up here a little bit. 25 minus 2 is not 22. That is indeed 23. So I'm going to say 200x equals 23. Oh, sorry, not 200x. Can you tell I'm tired? All right, 200 equals 23x. Then I'm going to divide both sides by 23. Divide by 23. So I have x equals about 8.7. And then, so that means that at 8.7 lawns that they're equal, but we're not going to talk about it. We're not going to split lawns up like that because that's just a little too tricky. So we're going to say about 9 lawns for when the revenue will exceed the expenses, right? Because if we round up, that means that we're going to make just a little bit more money. So 9 lawns would be the answer for this problem. Now, I want you to try answering this one on your own. So you're going to have to write 2 equations and then solve. The question states Fun Time Amusement Park charges $12.50 for admission and then 75 cents per ride. River's Edge Park charges $18.50 for admission and then 50 cents per ride. What is the number of rides? For what number of rides is the cost the same at both parks? Good luck. All right, hopefully when you set up this problem, you said Fun Time. The equation would be y equals 1250 plus 0.75x, and River's Edge would be 1850 plus 0.5x. And then you saw you had a y equals and a y equals, and you know you can just set those two things equal to each other. So you said 1250 plus 0.75x equals 1850 plus 0.5x. Then I showed you my work, my steps for solving for x, and that is going to be my answer. The answer is going to be 24 rides is when the cost is the same. And if I'm ever questioning my answer, what I can do is I can plug it into both equations. So I can plug 24 into the Fun Time equation, I can plug 24 into the River's Edge equation, and I should get the same number out of both of those. All right, so just a reminder, graphing is good. It's a nice visual, but sometimes it's really tough to graph some of the points. So whenever you need a more exact answer, like you can't just use an approximation, you're going to want to use substitution for now, okay? If you have any questions at all, please don't hesitate to reach out for some help. I am more than happy to assist you. Have a great day.